Well, I want to welcome you to the second in a series of what we call sustainability series here at the Friends of Two Rivers. My name's Warren Hampton, you guys probably know me. And we want to thank the Lutheran Church for letting us have the space tonight. Probably have another one of these sustainability lectures later in the fall, so be watching for that. I've got a little introduction for Dr. Renning here.
Oh, no.
Yeah. The challenge is to see if I can get through these big words. Steve Renning received a PhD in 1979 in forest ecology from Colorado State University. He's been with the University of Montana, Missoula since 1979, where he is a University Regents Professor of Ecology. Primary research interest is the development of global and regional ecosystem biogeochemical models integrating remote sensing with bioclimatology and terrestrial ecology. I'll probably explain that. He's a team member for the NASA Earth Observing System, moderate resolution imaging spectroradiometer, and he's responsible for the EOS Global Terrestrial Net Primary Production and Evapotranspiration datasets. You have to ask him about that one. He's published over 240 scientific articles and 2 books. Dr. Renning has recently served on the Standing Committee for Earth Studies of the National Research Council and on the Federal Interagency Carbon Cycle Science Committee. He recently has served as co-chair of the National Center for Atmospheric Research, Community Climate System Model Land Working Group. He's a member of the International Geosphere Biosphere Program Executive Committee and the World Climate Research Program Global Terrestrial Observing System. He currently serves on the advisory NASA Earth Science Subcommittee and the NOAA Science Advisory Board Climate Working Group. Dr. Renning shared the Nobel Peace Prize in 2007 as a chapter lead author for the 4th assessment of the Intergovernmental Panel on Climate Change. Dr. Renning is an elected fellow of the American Geophysical Union and is designated a highly cited researcher by the Institute for Scientific Information. In the popular press, his essay in 2007, The 5 Stages of Climate Grief, has been widely quoted. And I've read some of that, and I think I'm stuck in the depression mode.
Stage 4.
Stage 4 depression.
Yeah.
So
Aren't we all? Jeez.
Particularly with the legislature. And I'll please welcome Dr. Renning. I'll get out of the way.
Yeah.
Let me run back and hit the light.
Okay. Yeah, I'll give kind of a different talk tonight from just a pure climate talk, which after our 2007 report, I gave I gave the summary of the climate, a lot of talks on that, and after a couple of years, I found that that didn't really get us far enough towards a look at what we need to do as society. So this talk keeps evolving. And I guess that's good, because that means I'm not just giving the same thing over and over. And I'm going to be up Saturday night at the the Cabinet Mountain. There's an environmental group up there outside of Thompson Falls. So this is my warm up for that one. So here goes. One of the things I've learned from lots of these public talks is that you really have to get people you have to remind everybody about this basic point first, is that all of us think about the weather. We watch the weather on TV every night. We look in the morning what the weather's going to be to decide a jacket to put on and all that. So we're always thinking about the weather. And consequently, you see people making some really unfortunate observations, actually inaccurate statements. Like this winter when it got real snowy in Washington, D.C., you read these reports of people saying, well, what does Al Gore think now? Sort of things. Well, that's weather, just like our winter was colder, snowier weather than normal. What we're studying is climate, and as this says, you can't see any climate trend on less than a couple of decades at minimum. And I like to basically work with 50 years or more. Really, 1950 to the present is my favorite window of time. So anything that happens over the course of a few months or even a year or two doesn't tell me a thing about climate. It's like watching the Dow Jones Industrial Average yo-yo up and down and think it's telling you something about the economy. The second principle that I've found isn't obvious to a non-Earth scientist is that when we think of the whole Earth climate system, we somehow think that the atmosphere is really big and the sky is really, we call ourselves big sky, right? In the whole Earth system, I like to use this space shuttle shot because look at this just piece of the Earth's surface, but the atmosphere is really just a tiny, tiny skin above the Earth's surface. Really, it's only about as thick as from here to Missoula is the thickness of the primary atmosphere. Out of the whole Earth system, the atmosphere is the smallest part. And so once you realize that the atmosphere is not huge and infinite, but it's really the smallest part, then this becomes more obvious. This is the immortal Mauna Loa CO2 curve, as started by C.D. Keeling there, going up the snowball chairlift with me a few years back. And what it did is it showed humans for the very first time that we were having a global impact. Before this curve, we could imagine that we really were tiny ants on a giant planet. Now we couldn't kid ourselves. We could see that we were causing the CO2 of the entire global atmosphere to go up. And this is now measured all over the world in hundreds of places, so we know this with very high accuracy. It's interesting that one of the things Dave Keeling, who used to come up to my lab all the time, he's the most famous Earth scientist in the world. In 1968, look what he wrote. The rise in CO2 is proceeding so slowly, we'll probably go our whole lives without realizing something's wrong. Gee, I wish that was true. I mean, here we are, 2011, and it's all too obvious that something's wrong. And so, back then we were so innocent. I mean, even through the 1980s, I imagined that this was a problem that would show up at 2050 or 2100, a long time from now. We had lots of time to kind of get ourselves straightened out. And so it really has been, even for us as specialists, only in the last about 15 years that we just see the acceleration of these things in the Earth system that I'm going to show you now and realize we don't have 50 or 100 years to get ready. I always find it interesting when some of the climate denier crowd, as they're often called, talk about the greenhouse effect as if it's some mysterious theory that's really not been well established. Svan Arrhenius figured it out in 1896. So this is basic physics that's been known for a century or more, that you have gases that the molecules exhibit this greenhouse sort of effect, that solar radiation can come through, but thermal radiation, heat radiation, can't go back out. And that's just like a pane of glass works. Light goes through a pane of glass, but heat does not go back out, and that's why your car gets hot sitting in the sun. That's why your greenhouse can be 100 degrees inside, even in the winter time when it's a sunny afternoon, is this basic principle. And so this is well-known physics. There's nothing mysterious and unknown about it. So what the scientists do is attempt to understand all the pieces of the Earth system that influence the energy coming in and the energy going back out, of which these greenhouse gases are some of the most important, or are the most important, but a lot of other things factor in, and they've looked at. People hypothesize that the sun's gotten brighter, for example. Well, we measure the sun very accurately, and the sun has only gotten just infinitesimally brighter. And so we know that is not the cause of what we're looking at. We can look at global snow cover and aerosols and even airplane contrails. And when we add together all these factors that influence the global energy budget, what we find is that the increase in trapped energy that's occurring now is equal to about 1.2 watts per meter squared. And the best way to think of that, because otherwise it means almost nothing to any of us, imagine the little Christmas tree light on an area about the size of this table. And then imagine one of those Christmas tree lights of energy every square meter around the whole planet. That's the additional heat energy that we are now trapping from this greenhouse effect, and in an ongoing way. So we're accumulating this 1.2 watts per meter squared year after year after year of additional energy over this last half century. And the expected result, Arrhenius literally predicted this in 1896, is that as that CO2 goes up in the atmosphere, at some point the Earth's atmosphere will start to warm up. And sure enough, this is a graph since 1850, you get a sense of normal variability here, and maybe you can't even tell that this is a trend yet until you get to these last about 30, 40 years. And now, decade after decade, we just keep setting new records of temperature in the global atmosphere. And it was in the paper about 2 months ago that 2010 tied, I think it was 1998, for the hottest temperature ever recorded since records began in 1850. So over the period that we have a good weather station data, these 2 years have been the hottest. And even more than that, the decade of the 2000s has been the hottest decade. Before that, the 1990s was the hottest. And so you literally are seeing, we just never have these downturns anymore, is the deal. We just keep having a record, and then a next record, and then a next record going up. It's important to remember that these are global summaries. One of the other things that I think people don't think through correctly is, it was a pretty cool summer here last summer, wasn't it? If you remember, we didn't hit 100 one time. Well, Moscow, Russia had the hottest summer in 500 years. And so you can't at all imagine what the global temperature is doing without taking a global look at all the data. And no matter what it's doing in your one spot, you can't make any assumptions of the final global averages, which is what this illustrates. Now, something we didn't understand at all when I was an undergraduate, so this is really science that's developed in the last 40 years, is that where's this 1.2 watts per square meter gone? Not in the atmosphere, it's all in the ocean. 90% of this additional energy is in the ocean. And the ocean circulates with this great conveyor belt, as they call it. And this is what brings us El Niños and La Niñas and these things that you read about in the paper. What those are actually referring to is ocean temperatures. And so when they talk about an El Nino occurring, what they're actually talking about is ocean temperatures way out here along the South American coast. And so we now know that when we look at these last 50 years of where all this energy has gone, the land and the atmosphere is hardly, they're too small. They're a tiny reservoir. This is in the ocean. And we know it's 10 to the 22nd joules of energy, they calculate, has been added to the ocean in the last 50 years. And so this is based on zillions of ship temperature measurements. One of the things the ocean's doing as it warms up is expanding. This is what water always does. And so the sea level's rising. Some people think this is going to be the most damaging part of climate change for humanity as a whole, is rising sea level, because more of the global population lives around the coasts than anywhere else. We're actually highly abnormal to be this far from a coastline, and I'll bet we all like it that way. But when you look at the world as a whole and all the big cities on the coastline, this is where sea level rise becomes a really big deal. And we expect now that sea level will go up 3 feet this century. Is probably our best guess now. This is driven partly by the warming water, but it's mostly by ice melting on glaciers and the Greenland ice sheet in Antarctica. And so the way we get those increase in sea level is to be looking at the ice melting. Now, one other ocean topic that we're spending a lot of time looking at now it's really come about pretty recently. The understanding is that when you have CO2 in the atmosphere, some of it dissolves in the water, just like when you have soda pop and CO2 in soda pop, just a bit. But what it does is it forms a weak carbonic acid with the water. And so the ocean is acidifying. Just by a bit. It doesn't seem like much, but where that appears to matter is a lot of shellfish, well, all shellfish, coral reefs, they build their shells with calcium carbonate, and that is very pH sensitive. And so if the pH becomes too acidic, they can't build a shell anymore. And so this has gotten a lot of attention just in the last decade to see what potential there is for that to happen. Now, the other signal that we look at a lot is the sea ice on the Arctic Ocean. And we've been able to follow that since 1979 because we've had satellites up. And of course, being able to see white ice and dark blue water is very easy. So we have a very good measure of this since the very first satellites. And this is what the sea ice used to be in late summer. So at the end of the summer melt, it used to still be about this big. And now you see that we've lost 40% of that. So every summer, the ice sheet is melting more and more. We expect that within 20 or 30 years, we will hit the summer where the entire Arctic Ocean goes ice-free. And it'll still be, of course, icing up in the wintertime, but it'll be ice-free just the way our lakes, ice up and then melt out in the summer. And of course, this they don't think this has happened in, eons. And so that'll be a difference for the planet that is unprecedented. If you go to the other end of the world, they map temperatures in Antarctica, and you can see that all through this West Antarctic arm and the lower Antarctic shelf, there's been on the order of a 1 degree increase in temperature. Now, it's still plenty cold there. And so this doesn't imply that the Antarctic is going to melt out. In fact, you know what the annual high temperature is at the South Pole? About 5 or 10 below. The high temperature for the year is 5 or 10 below. So big deal if that goes up 5 degrees, then it's what, 0? So if anybody tells you that Antarctica is gonna be melting out in any time soon, they're really just alarmist. And I can assure you we do not need any alarmists. There's enough real things to look at without trumping up something more. And of course, when you talk about melting ice, the icon of North America is our own Glacier National Park. And I think, well, my friend that does the measurements up there says the glaciers will be gone by 2020 now. And I think the day, in fact, I've told him he should announce that the day he retires. It would be a good way to go out, because I think it'll make world headlines the day it's announced. It's amazing how many people know about Glacier National Park around the world. When I introduce myself at an international meeting, yeah, I'm from Montana, almost invariably they'll say, now isn't that where Glacier National Park is, where the glaciers are melting? And so when you have a name like that, and it's widely known that the glaciers are probably only a decade away from being gone, people know. They hear about it all over the world. All right, let's zoom in a bit and see what we see happening around here. First off, as I said, the ocean temperatures we see are the most important thing to look at. And sure enough, they've gone up a couple of degrees Fahrenheit in the last 50 years. So I grew up in Seattle, and we used to go out and go swimming in the ocean. And this looks like the ocean temperature was about 48 degrees at the time. Oh man. This is proof of how children's brains are not fully developed. I don't know any other conclusion to draw. Now, what we know all through the Northwest here is when you look, we're looking at about, in this case, 80 years of record, 85 years of record, 1920 to about the present, that overall, throughout the Northwest, we've gained, on average, 1.5 degrees in temperature. We've actually gained a bit on precipitation too. We sometimes wonder that around here, and of course they didn't have very many stations here. They stopped this study at the Continental Divide. But we see precipitation staying about even to possibly going up a little bit over these 50, 60, 80 years of record. What we want to think about to try to understand what to expect in our temperature regime is, this is a nice graphic that I find is really helpful. If you were to take any weather station and plot the year's temperatures on a graph, it would look about like this. The coldest temperatures of the year would be down here, and the hottest temperatures would be up here. The average temperature for the year would be here. And we guesstimated be kind of one of these bell curves, as they call them in statistics. What we expect climate change is doing is just shifting that distribution over a bit by these couple of degrees. And so one of the things that's worth noticing is there's going to be a lot of days in the middle of this distribution that are perfectly normal from before. And today's a good example. Today's temperatures are not the slightest bit abnormal for 50 or 60 years ago. And so it's easy to say, well, it doesn't seem like anything going on. This is kind of day we would have. But you look at that graph and you can immediately see where you would expect to see big differences. And that's on the edges. These low temperatures, these high temperatures. So let's do it. We took Missoula. We took a whole decades of data, not just 1 year. We took the 1950s and then the 2000s and plotted this same, as I call it, histogram or frequency distribution from the coldest to the hottest. And here's what it looks like. And sure enough, in through the middle, everything more or less looks about the same. But let's zoom into those two edges. And let's first look at the top edge. And so here's the 1950s. And what this tells you is it only went above 100 degrees maybe a couple of times in the entire decade in the 50s. Okay, in 10 years, it only exceeded 100 in Missoula. This is Missoula Airport data, just a couple of times in 10 years. Whereas in the 2000s, you can see a fair number. I know it's kind of hard to interpret these graphics, but you can see that there's a lot more room under this curve above 100 and certainly above 95. You see just tremendously more days above 95 than used to happen. And in fact, of course, probably almost all of you were here for our immortal July 07 when we broke every temperature record we had, including the hottest day, the hottest night, 11 days over 100 degrees in 1 month. Luckily, it hasn't had a repeat, but it certainly looks a lot like what the theory would suggest, doesn't it? That at least periodically we have way warmer temperatures than what we would have 50 years ago. Now we look at the other end of the curve, and we were talking about that just before we started here, the cold temperatures. In the 50s, we had some temperatures right here in Missoula, 35 below zero, 25, 20 below zero. I don't remember the last time we hit 20 below here. I think it's sometime in the 80s is the last time we hit 20 below, even once. And so now we find that if we go below zero a handful of nights a year, that's about it. This year, I tend to keep track of these. I count them up in my head. I think we made about 6 or 7 nights below zero this year, which is a lot more than we have in a decade. But even then, they were only 6 and 8 and 10 degrees below zero. None of this 20 and 30 below zero at all. So I think from what the theory suggests to what we look at in our local weather patterns, it looks about right. And what we have to imagine is in 50 more years, a continuing shift of about the same sort of magnitude. I try to give people a sense of where it seems like our climate will go, and that would take us into something like Salt Lake City. So, I mean, it certainly isn't going to be uninhabitable or anything like that, but it isn't going to be like this. And of course, we're having a great snow year now, but this is the day that our big climate report came out back in 07. Look at that, March 4th on a north-facing slope at 7,000 feet. So we've had some spectacularly unsnowy winters in the last decade. And of course, some of that is absolutely natural. You go back through the records, and even back in the 30s and things, we had some years that were quite snow-free and very low overall precip, very low snowpack. And so you don't want to say that any one year is somehow amazingly abnormal. You have to look at decades of data and look at the overall trend. So what we see, just to summarize what we're seeing with our snowpack here, this is 50 years of record for the whole Northwest, and it's the measure of the snowpack on April 1st. Now, USGS and the Snow Survey, the SNOTEL sites that are all around the western U.S. have always used April 1st. That used to be the peak of the winter snowpack before things started to melt out. Well, nowadays it isn't the peak anymore. Most years, snow has already been melting for 2 or 3 or 4 weeks. This year will be more, again, more like average, where it will be a peak just about April 1st. But overall, what you see is 30 or 40% lower snowpack on April 1st than 50 years ago. That doesn't mean that it was lower all winter long. It does mean that once the peak occurred, it starts melting earlier, and we're seeing this quite clearly as a decadal pattern. Now, some of that might even be good news for things like spring flooding, but what we're most concerned about with this earlier snow melt is the end of the season, the end of the summer stream flow. And think of how many summers in the last decade that they've had to close the fishing in July and August. And it all comes on the news that the trout streams, first they limit it to morning and evening fishing, and you can't fish from 10 till 4 in the heat of the day, and then they close it down all the way. That's all about stream temperature. And what's happening is the flow through our streams. This is 50 years, 57 years on all these rivers, and this is their August flow rate. Their rate of flow from 1950 to the present. Every one of these rivers has gone down in total something like 20 or 30%. Now that is not all climate. It's a combination of climate and irrigation withdrawal. And so we don't want to overinterpret this climatically, but as an aquatic ecologist, you come to the same conclusion. We're losing water in these streams at the time of year they need it the most. Now some of our landowners and community groups have gotten really quite organized on this. The Big Hole has a whole group of a combination of landowners and government scientists and NGO groups and recreational groups, and they have this whole big program. I've given a talk for them a couple years ago, and they're really on top of this. They know darn well this is the reality, and that the what they have to do is start off with looking at what the spring snowpack looks like, forecast forward into the summer. Of course, our forecast for this summer is great so far because we have this great snowpack. But it's too early to get overconfident because we really have to see how warm the spring is and how fast it melts out. And what they do in the Big Hole is they can see weeks ahead if they're really going to hit bottom. And then the farmers will quit irrigating. They'll put some of their water back in the stream, and I don't know what kind of financial arrangement was made for that, but I know it's what they do. And so they have very tangible things that they're doing to keep the August flow rate up. And I think we're going to have to be doing that all around Montana in the future. So a couple of looks at other things we're seeing. First off, if you're a gardener, this is nothing but good news. Our frost-free growing season is about 2 weeks longer than it was 50 years ago, right here in Missoula, and really all across the northern part of the country. This is pretty common, is that we see on the order of 2 weeks longer. And so you put that together with those losing those rock bottom minimum temperatures, and we're getting to the point where we can grow apricots and peaches and some of those kind of cool but not cold climate fruits, for example, that we couldn't do 50 years ago. So our gardening environment is changing here, and by and large for the better, as long as you have water is the key ingredient. Our biggest problem isn't sea level rise, it's the specter of just massive wildfires. And 3 or 4 summers in the last decade, you know we have had fires going in every direction all around town. And if we would have had the kind of wind event that 1910 would have had, it would have been 1910 all over again. And so we're walking this tightrope of probability right now. That is what concerns me the most. I think for Montana, this is the highest potential for true human death and destruction. You know, this is our earthquake and tsunami for us, is wildfires. And just the way we look at these pictures of Japan, and they're just incredulous. The potential is that could be us with a wildfire one of these summers. And you hope it doesn't happen, but in the meantime, you have to do whatever preparation you can. The other big impact we're seeing, and I guess I'll add before I go past that, one of the reasons that we're trying to put this cogen plant at the university for electric power and biofuel fueled plant is to be able to clean up the beetle-killed trees all around the town and be able to build a more fire defensible perimeter for the whole community. I mean, we've got free firewood in every direction from town that's standing dead, and yet it has no value at all in the normal wood market. The only value it has is if we can make it an energy source. And these cogen plants actually produce electric power and heat. And so you've probably read something about the plant being planned for a campus. I think we're getting closer. They haven't let a contract yet because there's been all these engineering studies and public comment, but I think we're getting there. And part of the justification for that totally is to be able to have a market for that dead fuel to be able to try to fireproof our communities. And to me, that's a very serious business for that reason there. All right, the other thing, well, I guess the related thing, is these huge insect epidemics that we've never seen anything like it before. Mountain pine beetle is endemic in our forest. They're always there. But in the past, they never could get revved up the way they've gotten revved up in the last decade or so. And we understand now that that's a combination of these easy winters, that none of them freeze to death through the winter, and then these long dry summers that stress the host trees so they can't fight back as well. And then you have stands that are 1910 is 100 years ago. What do you know? 100-year-old pine, lodgepole pine forests tend to be thick and overgrown and decadent at that age. And so we have a combination of stand histories, summer climate, and winter climate all put together, and then fire suppression to ice the cake to have fuel buildup that would have never happened naturally. So you actually have 4 different reasons that these epidemics have taken off the way they have. All right, so what do we think is coming? We take these GCMs, global climate models, and of course they try to simulate the climate of the whole world for the next 100 years. And what we then do is zoom in to just our region and downscale it, as it's called, so we can take a look at our part of the world as a piece of those GCMs. And what they show, this is for maybe 30, 40 years from now. These aren't, obviously extremely accurate because they're a projective of decades into the future. And so this is wintertime, December, January, February. Temperatures a couple of degrees warmer than they are now. And what that will mean, unfortunately, is we'll have more of these thaw and rain events in the dead of winter than we have in the past. But it'll still be below freezing most of the time. We're still going to get a pretty normal snowpack on most years. The models think we may even get more winter precip. And so there's no evidence that that's happened yet when we look at the direct weather data, but this is what the models project might be happening in the future. But the summertime really looks ominous. Here again, 4 and 5 degrees, those are degrees centigrade, warmer temperatures, and if anything, less summer rainfall is what they project. And so, I can't help but conclude this, that we just simply will not have enough molecules for irrigated agriculture and rivers. We're going to have one or the other. But I don't see any way that 50 years from now we're going to have the same amount of water to work with that we do now. It just isn't in the cards one bit. And so when I give this talk to water managers and water lawyers, I tell them, you better, the Colorado Basin's already thick into this. You talk to Arizona and California, they've already hit the wall. Lake Powell's at its slowest point, and Lake Mead in decades. We're going to be on our way, and the sooner we plan for it, the less it's going to hurt. So that's a summary of the climate part. And so now I'm going to switch gears on you and in effect start talking about the causal end of the whole thing. And basically we're going to talk about carbon and carbon and CO2, and basically what's the driver of these climate trends we're seeing, and what kind of corner is humanity boxing itself into. And the first principle that I think is important for Americans to understand is we are in China's tailpipe. And all the pollution of China, and these clouds we can follow by satellite from space. They come right across the ocean and come right over us. All the particulate and smoke and the CO2. And when we look at fossil fuel emissions of the last decade, the US is just about plateaued. And in fact, we peaked in gasoline consumption in 2005. It looks like we may have peaked in overall energy consumption, as you can see from this graph in 07. But look at China. It's just off like a rocket. Now, I'm not saying this to bash China, though, because when you look at the per person carbon emission, they have 5 times as many people as we do. And outside their splashy cities, they still have hundreds of millions of people literally living in mud huts. Because I've been there twice. And we see all the glitz in Beijing and stuff. They never show you the back, the rural areas out in the outback. So they have 500 million people that still don't have what we would call access to minimal electric power, or did we do that? And nobody knows. And so the whole world, I mean, this is us. Our per person carbon consumption is the highest in the world. And so everybody's waiting for us. We like to be the leaders in everything else. We brag about being the world leaders in everything else until we come to this topic, and all of a sudden we don't want to lead anymore. And don't think the rest of the world can't see through it. They can see through it in spades. And what we as earth scientists see is a trajectory like this. We are right here in 2010. By the end of the century would take us 6 degrees centigrade. That's like 11 degrees Fahrenheit warmer than current temperatures. We are suspicious that isn't even a viable planet anymore. So in the next century, we see that a business as usual lifestyle for the planet will literally take us over the edge. And so we don't see that there's any option but some sort of changes happening. And in fact, I talked to some of these, probably the best risk analyzers in our society are our insurance agents. They analyze risk all the time. And what they, kind of a common principle of quantifying risk is you look at the probability of whatever this bad thing's going to be, and then the consequence. So every time we buy insurance, we're making this evaluation in our head that even though the probability of, say, our house burning down is pretty low, it's actually very low, the consequence of our house burning down is we lose everything. So we buy insurance. So if our luck goes bad and our house burns up, we have something to rebuild a new house. And I mean, to us, we see the world right now, it's like having your kid in the front seat of a Ferrari going 200 miles an hour and you don't even bother with a seatbelt for him. Is the way we see the planet going at the moment. I mean, we don't know the probability perfectly of risk. We're quite suspicious, but it isn't perfect. But the consequences are so profound for humanity as a whole that we're thinking, boy, don't you think we ought to buy a little insurance here? And that's really what we're fundamentally talking about when it gets down to a risk analysis. So then you start looking around of what's the problem here. You can't see from this is 2004, 7 years ago. We have been walking a tightrope in the global oil supply for 7, 8 years now. And this is a very revealing graph. And this comes from the oil industry, not from a bunch of hippies. And what this graph shows is back in the 40s, 50s, 60s, the discoveries, they discovered huge big oil fields. 1 year's discovery would be 20 years worth of global consumption. Since 1990, every single year, we've used more oil than we've discovered. So for 20 years now, we've been deficit spending. And the ratio now is about 3 to 1. That we consume 3 barrels of oil for every 1 barrel we find. I'm just waiting for this oil bomb to go off. And this may be the summer. You read the news, what's going on in the Middle East. It wouldn't surprise me one bit if gas is $7 a gallon by August. And if it isn't this August, I think it's going to be within 5 years. And think about what that's going to do to American lifestyle. And most Americans are so oblivious to this, I am just astonished. Because this says, you see the cover of National Geographic, we've been teetering on this edge for a good half dozen years now. This isn't just overnight, one bit. All sorts of analysts are analyzing and predicting this. And of course, every year that we squeak through, a certain fraction says, well, look, no problem after all, we made it. I don't know how much longer. Think of that. 3 barrels of oil consumed for every oil discovered right now. And so how much longer can this go? And of course, what we now totally see is how much harder they have to work to get that barrel. And that's absolutely what's going on now, is the easy barrels where you just go out in Texas or Wyoming, drill a well a few miles and out it squirts. Those days are coming rapidly to an end. Look at what they're having to do in the Gulf to get oil. And this is what is going on all around the world, is they're having to work harder and harder, and of course spend more and more money to get that barrel of oil. And of course then, as we all well know, this is what's next, is the tar sands. And we've become innocent collateral damage for that now, haven't we? And you recognize that that is the highest carbon emission for processing of any barrel of oil we could get is tar sands oil. So yes, you can get a barrel of oil out there if you work at it hard enough. But your carbon emissions to dig that tar up, you know, they dig up this dirt by the dump truck load, and dump trucks the size of this room. And then they have to heat it up. Think of all the energy to heat up mounds of dirt. And you have to heat it enough so the tar starts to flow, and then they can squeeze it out. And that's how they get oil out of it. So it's an unbelievably energy-intensive way of getting a barrel of oil, but it's what they now have to do to come up with oil in any kind of big quantities. And then there's coal. I love this ad by, she's so naughty she deserves coal for the rest of her life. You know, these power plants use one train car every 5 minutes. That's what something like a coal strip plant goes through, a train car every 5 minutes. One of the most amazing bits of economics that I see, I can't get over this, is that they can dig up coal in eastern Montana, put it on a train, ship it to Seattle, put it on a barge, ship it to China, put it on another train and ship it into to the power plant in China and burn it, and it adds up economically. You're dragging coal that far to burn, and it's an emissions disaster, it's a financial disaster, and then we have a governor that just signed Otter Creek for 50 more years of digging oil. It's the worst way to get energy I can think of. And then we recognize that in our government, we're giving massive subsidies to these companies that are the richest companies on earth. So here we have $1 trillion plus deficit. We're effectively bankrupt. And yet this is a mapping of federal subsidies for fossil fuels and renewable energy. And it's a combination of tax credits and direct subsidies of various types. And they've tried to add this all together. And the oil industry gets something like $70 billion a year of tax breaks. Why? Well, I guess just before Christmas, they couldn't even see fit to the taxes on the millionaires. They had to cut those. I just find it unbelievable. We are drowning in red ink, and yet we're still giving tax breaks to Donald Trump and Exxon. And then we wonder why we're broke. It's just unbelievable. I really value some of these people like Warren Buffett and Bill Gates' dad, that they say out loud, we are billionaires, you guys are fools, you should be taxing the hell, we could pay triple the taxes we're paying and not even know the difference. And yet then they extend the tax breaks so they can keep their yacht going or something. It's just nuts. If we had a federal surplus, maybe okay, but we're broke. I can't believe the deficits we're running now. In my lifetime, we never even imagined a federal deficit could go as high as they now are. And yet we're still giving out tax breaks to the richest companies on earth. So people have asked me for a long time about cap and trade, all this carbon cap and trade. And I really saw that to be a big poker game. There's not one politician that will stand up and say this out loud, but we should raise taxes. And we should raise taxes on carbon emissions. And so that any energy source that doesn't emit carbon gets a competitive advantage, and any one that does basically pays for the damage they're doing to the Earth system. And yet when they try to talk about this in any legislative body, it gets nowhere. And yet it's the most direct way that we could improve both the development of other energy sources and reduction of demand. And when I talk about reduction in demand, it's unbelievable how much America could easily do if we wanted to. I find this graph really amazing. This is the per person electric power consumption by America as a whole, which as you can see has gone up pretty steadily to about 12,000 kilowatt hours. And then this is the same thing for California. Look, the average Californian use almost half of what the rest of us do, because they, for decades, starting about 1970, had very strict regulations on home construction, on heating and cooling engineering. I mean, this is where all the standards for like air conditioners and things like that came from, was from California. And so by pushing these technology thresholds, they use half the electricity of the rest of us. And whenever I go down there, I don't see them living too impoverished of a lifestyle. I think it really tells me how much power we could do. We could close so many coal plants if the whole country just closed that gap. We could close dozens of coal-fired power plants tomorrow. And so what I see the last 40 years has brought, and it's interesting to lecture to undergraduates. They don't even know what some of these are. they are clueless. Of course, I'm clueless at how to work that, so that makes us even. I actually went from a smartphone, I dropped back to a dumb phone about a week ago. Here's my dumb phone. They're just, I don't want a computer in my top pocket. I get tired of computers. What we've got to do is the same sort of revolution that we've had in information and computing of the last 40 years. Now we have to do the same thing for energy. And so in 2050, let's hope our kids and grandkids look back on the Stone Age of 2011 and laugh at what a joke it was now. Because that's what we need to do to get out of this pickle we're in. I think one of our biggest impediments now is who's calling the shots, running the country. Right now, basically Wall Street runs the country, and of course their guru of all time, Alan Greenspan, this is what he said in front of Congress in 2008. Gee, we thought we knew how the world worked, and whoops, we lost $30 trillion, and we don't know why. We don't know what went wrong. I would submit that we know more about the climate and the carbon cycle and the Earth system than they know about the economic system, and yet they call all the shots. And I really see that the most overarching problem of all is that we have economics and economists making all the decisions, and all they want to do is grow more faster. Every single economist you see on TV talks about how we got to get growing the economy again as quick as we can. And so I have the privilege, I recognize it's a privilege as an academic, to be one of the few people that sits around thinking about what the world's going to be like in a half century. I'll bet none of you in your job have that task at all. Hardly any normal people do. And yet that's what I do for a living. And unfortunately, almost no politicians do that kind of long-range thinking. And the other problem is no politicians manage the whole world. We have no global orchestrated governance. The UN is a pale a pale and feeble facsimile of global governance that in no way is up for the kind of things we have to do over the next half century, and yet that's what it'll take for us to end the century successfully. Instead, we have politicians that come up with stuff like this. This is our beloved Montana Congress. That made, as you can see, that was rattled around the national press the day that went in. We could be proud of that. One of the things that this was a really interesting study that taught me a lot about just what is the deal with American public. You know, we've got all this information and data and reports come out, and this study helped me understand what's going on. When you look, the proportion of the adult population that they found specifically on the topic of global warming, what their opinions were. And so I suppose I'm over here in this alarmed part, which is different than the depressed part. It's the alarmed part. And then concerned is the next category. Notice the two of those together is half the population. On the other extreme, the climate denier, they're very noisy, but it turns out they're a pretty small minority. And I've seen a number of studies. They never come up as more than 10%. And for all the press they get, you know there's money pushing it because it isn't just volume of people. I think our biggest problem now is right in here. We have on the order of 40 to 50% of the adult public that just isn't engaged on this or any other complicated topic. You can list hard topics right down the list of difficult problems we have in society, and they just don't take the intellectual energy to get informed, to vote, to give a damn. And I think that's where our problem is. It certainly isn't this 50%, and I don't even bother with this 7%. I'm sure nothing I can say is going to change their mind, so we'll just let them squeal away over there. But geez, 50% of the population, somehow we need to get them to at least wake up to, in some passive way, work along with the things that have to start happening. And so I've started reading, I quit reading climate science. I don't read that anymore at all. Well, I have to get paid, I have to read some of it. But I've spent, in the last couple years, more time, you might say, in the social science literature, looking at how they basically decipher and register the state of the world. And they try to put together things like this Happy Planet Index, which they now call the Unhappy Planet, and the idea that we need to dethrone the concept that maximizing growth in measured economic prosperity should be the objective of the country. This is my favorite one. Robert Kennedy. Gross domestic product measures everything except that which makes life worthwhile. Isn't that classic? This is a really good book I just found, Beyond GDP, The Need for New Measures of Progress. And it just came out a couple years ago. So there's a fringe, and I have to admit they're a fringe of, you might call them environmental or ecological economists that are absolutely on the same wavelength that we are, and seeing that the planet is on a stunningly unsustainable trajectory in multiple different dimensions. Climate is only one of them. And they really see that this is more than just stop and burning oil. It's a bigger rethink of what drives society. So I just finished this book just a couple weeks ago, Mismeasuring Our Lives, Why GDP Doesn't Add Up. And the author's a Nobel laureate in economics, so he isn't just some quack. He was the head economist of the World Bank, so he has credentials to burn, and that's his opinion too. So you fall into things like this. In Bhutan, their king explicitly, officially announced a number of years ago that they would not maximize gross national product or economic development. They would maximize gross national happiness. And you can't help but think, oh, isn't this kind of corny? But get past that and start thinking harder about what it tells us. I think I'm reading a lot of this kind of material now of what should we be aspiring to as citizens, and basically where should we be trying to go, both ourselves and to take the planet. And we're trying to do this in this climate change studies program that we've started at the university. And you can read, I just did this afternoon, this collage of disaster books on Amazon. You know, I got one of these Kindles. Boy, those things for what do you call it, impulse shopping are a disaster, because you can see a title, and in under 30 seconds I can go ding, 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 and it downloads. And of course I just paid $10 and I've got it. But it's unbelievable the number of books coming out with some of them are about climate, some of them about peak oil, some are about overpopulation, but certainly a number of them are about economic instability, national security crisis. There's sure a lot of people that are concerned with the trajectory of the planet. And maybe it's always been this way. I was never one of these doomsdayers before, so maybe there was always these books, but I don't think so. I think there's an awful lot of people reading the same tea leaves I am and saying, boy, this isn't going to add up much longer. But this is the book that I'll leave you with. Plenitude. Just came out about 4 months ago. She's a sociology and economics professor at Boston College. She's written for years about American overconsumption. And she's now she put more pieces of the puzzle together than any one book I have ever read. And to really an enlightened and entirely possible conclusion. And the bottom line starts with working less. Of course, along with working less is getting paid less. But in Montana, aren't we already used to that? So we're already at step one here, so we're on a roll. She points out that with all this spare time, Americans particularly could go back to doing an awful lot more of the stuff that now they pay to have done. And this is just like the 60s is all it is. For us, it's just going back to what it was when we were kids. She's very big on just smarter consumerism, because that's been her specialty for a long time. And one of the things that was really fascinating is she talked in great detail how important it is to just rebuild your communities, to just do more stuff instead of every time you have a spare weekend flying to Las Vegas. Work harder at just doing stuff around your own town and making your own town the place you want to be. And then she weaves in all sorts of other things. But it's by far the most positive book that I've read that faces on these issues full on. She starts the very first sentence with the financial crash of '08. So she's not some bubble-headed optimist one bit. But if you need something to read, this is the one. Instead of reading all these, go read this one. Okay, that's it.
You have time for a couple questions?
Oh, yeah.
Okay.
Yeah, now that it's dark out, it doesn't matter.
One of the, I talked about being in the stage 4 depression mode and maybe moving into desperation mode. How is that different from being in the alarm mode that you talked about yourself being in?
Well, I guess to me the difference is you can be alarmed about something and yet feel confident that you have ideas of what to do about it. Whereas I think a depressed mode is you're alarmed about something and are pretty clueless how you're going to get out of it, is the difference. And I think one of the things that is so hard for most people to imagine is they hear a talk by somebody like me and they imagine that they have to walk home tonight, among other things. They don't realize we fully understand it'll take decades and decades to turn this corner, but we got to start, and we just aren't even starting. And so much of our momentum, so many of our incentives are now exactly backwards, like the tax breaks for Exxon. And so we don't, well, there's, I have colleagues that are various levels of rabid, I admit that. But at least most of us still drive our cars sometimes. Now, mine gets 50 miles a gallon, so it doesn't do too bad. But the big thing is not that this has to start overnight, is we just need to start the momentum. And that's what we just don't see. Certainly at a national level. This may be the classic issue where grassroots activism ends up getting the job done. And when you read some books, there's been issues in the past that the political leaders have just been too chicken to make the hard decisions until finally enough grassroots demand built that they finally realize, oh, the big majority of the country really wants us to do that. And so then kind of they're the last ones on board. And I'm getting this suspicion that's what this issue is going to be about. We have more local level, tangible activities around the country in places I go, state level in some of the states, although not all of them, than we do at the federal level. We can't even get the Senate to have a vote on the floor. Yeah.
When you mentioned $7 gas this next summer, 6 years ago when we were in Wales, we were paying $6.80 a gallon for gas then.
Yeah.
I don't see $7 gas as, it's going to put a hurt on a lot of people.
Yeah.
But it is going to also turn the key to some changes.
Yeah, I actually hope it happens. I think the sooner it happens, the better, because everybody will face up to it. Because you're right, Europe's been paying $8 a gallon for decades. Their countries, right after World War II, realized we have no oil of our own. We're going to pay through the nose for every barrel. We want to keep the incentives for our populace to really minimize oil use. And so they've taxed, the reason it's $8 is all taxes. I mean, everybody pays the same thing on the global market. And so they have always had high taxes on oil. And so for Europeans, they adjust in lifestyle and size of car and distance they drive. I mean, we've all seen the things over there. They don't seem to live too pitifully either, the ones I hang around with. And the other part of the global oil supply that not enough Americans pay attention to is, along with supply dwindling, China and India's demand is exploding. And you got to remember, China has more pocket change than we do. And so if we get into a bidding war for the last 1 million barrels of oil, guess who's going to win? And we better wise up quick, because if we wake up and this hits us, blindsides us, there's going to be a lot of people really hurting. And if they would work their way into this, I think some businesses and some people are going to just plain be in trouble. There's no two ways about it. But an awful lot of the rest of us could make some pretty simple adjustments, if we haven't already, and do just fine with $7 gas. I wouldn't like it. And what I wouldn't like the most, though, is the $7 going to Exxon. If the $7 would pay down the national debt, I would volunteer to pay $7 if it was paying down the national debt. The worst thing right now is that with no carbon tax, when we do pay $7, it all goes to Exxon.
Well, what was coming out today about the EPA putting some kind of, what was that?
Advertising propaganda on the radio.
Yes, but what was
you would
the-
use a hammer to fix your computer.
Yes, but what was the EP, they were.
Why should you
that
use
was
a
the way
40-year-old
EPA was
law?
you know.
Well, that's the disinformation campaign to do any sort of, yeah, I'm sure this is some fossil fuel crowd trying to just talk down any kind of carbon taxing.
They're trying to diminish the water quality regulations and the air quality regulations in the state of Montana. They're trying to reduce them so that we're more appealing to corporations for abuse, basically. And that's what that ad is about. It's, when you listen to the end of it, it was it's like Friends of Coal.
Yeah. Yeah, so both at the state level and the federal level, they're attacking the federal EPA for trying to, the Supreme Court authorized the federal EPA to regulate CO2 a couple of years ago, and this is what, and the EPA has said over and over that they consider that a last resort. They would much rather Congress develop some sort of carbon management. Well, we see how great that's doing. So the EPA is really the only national body that can do anything in the immediate future of any sort of carbon management.
But I hear that the EPA is going to be in just tremendous, it's going to be under tremendous attack.
Oh yeah, oh it already is. They're trying to reduce the budget as much as they can, and so they're attacking by cutting their budget, if they can pull it off, they're going to try to actually pass a law that would withdraw their authority to regulate CO2. What we see at the moment in Congress is an amazing number of people in Congress that just live in a fact-free world.
Or they make them up as they go along.
They just simply are not interested in the facts. They've made a decision of what they want to do, and it's certainly what it totally boils down to is they just want to keep living the way they're living. And what we see on a global basis in spades is there's no chance that's going to happen for the next decade and maybe not even the next few years. And in fact, we may be watching, and what we see around the world right now, we may be seeing the walls crumble. And while we could be positioning ourselves to absorb these future shocks, instead we're just hell-bent on trying to keep things up the way they've been. And there's just no chance that could continue.
Did you read that Germany just made the decision to not continue with their nuclear energy?
Yeah, I don't overreact to those sort of things. I guess I'm getting cynical. I've spent enough time in Washington. With the big crisis in Japan, I can fully imagine the German chancellor saying, well, we've got to show that we're paying attention. And so what they basically announced is we got to review all of our nuclear plants, which actually everybody should do. But I would almost bet that a couple months or a year from now, they'll say, well, okay, we reviewed them all, we've made some improvements, but if it's this or burning coal, we're going to keep our nukes going. So I don't overreact to those kind of headlines because I think that's what's going to happen. And it puts me in a kind of a curious position that I'm no big fan of nuclear power, but people often don't think what the alternative is. And of course the alternative is we could use half as much electricity, but that sure hasn't happened. And meanwhile, it's always interesting to compare the number of workers that have died in coal mines in the last 50 years versus nuclear power plants. It's unbelievable. It's like tens of thousands of people die in coal mines all the time, and nobody even notices. And there may be a couple that die in Japan of this nuclear thing, and that's quite sad, but the real bottom line is coal plants on both ends. And feeding them coal there's huge mortality. Don't even get me started with the mercury output of burning coal. We worry about the mercury in our CFL bulbs. Oh, come on. As long as we're burning coal strip, the mercury in your CFL bulb is a joke.
Yeah, I worked for the Forest Service a few years ago in cleaning tools during the fire season. And at the time, they didn't have any kind of ventilation or anything where we were doing the tools and
Yeah.
breathing a lot of dust.
Yeah.
I had my blood tested for mercury afterwards. It was off the chart.
Yeah. Yeah.
And it's from ash, from
Yeah.
the trees.
Yep. Yeah, I heard recently about the climate study satellite that was destroyed on takeoff.
Oh, yeah.
How's that going to affect, or what do you see?
We've lost two in a row. We lost the Orbiting Carbon Observatory 2 years ago, and then we lost this one called Glory a month ago.
My reading of high-level scientific journals, Popular Science, it mentions that there's actually a climate study satellite in storage somewhere that they could bring out and send up. Is that?
Well, there's a lot of satellites and pieces of satellites around, so I'm not sure what. I wonder if they're referring to Al Gore's Terminus satellite, which would have some value. Every satellite launch costs $50 million. And so there's a very careful prioritization of what goes up. And one of the biggest reasons we're grounding the shuttle fleet is every one of those costs $400 million to launch. Okay.
Their cruise missile is 1.4 million.
Yeah.
Yeah, that sounds about right. Yeah.
Well, you mentioned Schweitzer, but you weren't quite pleased with him.
Well, that Otter Creek
Yeah.
decision.
Is there anything good that he's doing for this?
Yeah, it's hard to figure him out because he'll do that one day and the next day he'll be up there, closing down mining leases in the Flathead. And so the thing that's so outrageous about decisions like Otter Creek in Wyoming, I guess, just did something like this last week, is it obligates for decades and decades and decades into the future. If they signed a 10-year coal lease, I would have to say, well, we can't change that fast. We're going to have to be using coal for a while more. But do we have to sign 50-year leases? I hope it'll be so uneconomic that it never happens. And it's interesting to watch that the financial community that I love to trash sometimes is helping out in key ways. You just about can't build a new coal-fired power plant anymore because you can't get financial investment. The banks all expect carbon management to come sometime. And what that is an unknown risk of the value of that plant. And they just say, we won't loan you money for a coal plant. So dozens of them have been canceled in the last few years. Not due some grand environmental concern, is that they couldn't get financing. And we're actually seeing a shift from coal to natural gas happening relatively quickly at the moment in electric power production. And you get about half the carbon emission per unit of energy output with natural gas. And so that's a move in the right direction for right now.
Saying all this coal can go to China, though.
Oh, how that can add up to drag something like that 5,000 miles, I don't get it. Every time, you know, they go right through here. I'm riding my bike to work and there goes another coal train and I think, why am I even going to work today? Why don't I just stay home and drink heavily?